Hey friends, it's Andrew, and in this video we are going to be jumping into question number 33. Number 33 from the math test inside test 2 in your red book. So pause the video, flip to test 2, read number 33, and once you've read the question, hit play. Great. So number 33 we are dealing with, it's one of those questions where they give you one picture and then ask you a whole bunch of different questions about it. So I went ahead and, like in previous questions, I drew the picture from the book up here on the board so we can have something to look at. But in question number 33, what it wants us to find is the length of the segment FG. In other words, not along the curved line, but along the straight line, what is the length of this segment FG? Now there are two different ways that we can find the answer to this problem. Both of them require you to know a formula. There's actually two different formulas we can use here. So I'm going to show you kind of the geometry way to solve this problem and the algebra way to solve this problem. But both ways, the geometry way and the algebra way, they both require you to do two things. Use two of our code crackers. Remember, whenever we're doing calculations, we are using our calculator. So we're going to be using our calculator here. And anytime we use our calculator and are dealing with any type of exponents, we're going to be very careful with our parentheses. So we're going to be using these two code crackers on two different formulas to solve this problem. So I'm going to show you the geometry way to solve this problem first. Now when I look at this picture, and I want to find the length of this straight segment, FG, my brain has a siren going off. And it tells me, Andrew, there is a right triangle here. Let me show you. In this picture, what we're actually looking at, if you ignore the curved line and the shaded region, we're actually looking at a right triangle with this bottom side having a length of 200, because from 0 to 200 is where it's under this straight line, and this vertical side also has a length of 200. So we have a right triangle where the two shorter sides are 200, and we want to find the length of FG, which is the hypotenuse of a right triangle. So we can use everybody's favorite formula here, the Pythagorean theorem. And of course we'll do this on our calculator to solve for our hypotenuse, which of course we call C. And we will have 200 squared plus 200 squared, remember I put my base and my exponent in parentheses, equals C squared. So on your calculator I would type in 200 squared plus 200 squared. I don't know if I actually know what the answer to that is. 200 squared plus 200 squared. I do. It is 80,000 equals C squared. In order to find the length of just C, not C squared, I'm going to take the square root of both sides. And when I do that, I find that C is equal to 282.84 or something like that. 282.84, and this rounds up to 283. So 283 is one of our answer choices. That's answer choice D. So your answer is D. And we found that by using a calculator and the Pythagorean theorem. But there's actually another way to solve this problem. There's another formula that we can use to find the length of FG. And I'm going to show you that right now. So that was the geometry way. I want to solve this the algebra way. And if you want to find this answer the algebra way, you're going to need to know something called the distance formula. And the distance formula calculates distance between any 2 points. And the formula looks like this. You've seen it before. Formula looks like this. x1 minus x2 squared plus y2 minus y1 squared. And all it wants us to do is we have 2 points, x1, y1, and x2, y2, And if we plug the points into this formula, the coordinates into this formula, it will tell us the distance between those 2 points. So let's do this with this line, FG. You see that the line FG is actually the distance between 0, 200. So our first point is 0, 200. And our second point is 200, 0. So we want to find the distance between these 2 points. We can use the distance formula on our calculators. We're just going to substitute this into the formula. So let's call this point number 1 and this point number 2. So this is x1, y1, x2, x2, y2. So x2, we're going to plug into our formula, is 200 minus x1, which is 0 squared, plus y2, which is 0, minus y1, which is 200 squared. Plug all of that into your calculator, hit enter, and again, it'll give you like 282.84, which rounds up to 283. So your answer is 283, and that's answer choice D.